Hello. Let's now look at getting started with Snowflake with some hands-on. I have provided a link to the hands-on lab here on this slide. Snowflake provides these interesting quick start guides to play around with Snowflake environment. As you can see here, there are a number of them, including the ones on machine learning one. The one we are going to use is Zero to Snowflake. This lab takes us through making use of Snowflake environment for analyzing some stock related data, the SEC filings data. In this process, we will create Snowflake objects like databases, tables, load some data. We will also learn the concept of Snowflake Data Marketplace and consumer data set from there. Finally, we will use some key features of Snowflake like zero copy cloning, time travel, role-based access controls, and so on. So let's get started. The first thing for this lab is to sign up for a trial account. You can see this link over here, signup.snowflake.com. And it asks you for some basic information which you can fill up here. So let me see, let me put my, you can also put your personal email IDs here, by the way. And you can see here the Snowflake editions. We talked about the Snowflake editions previously. Standard is something which has the core capabilities and the most cost-effective one. Enterprise is the most popular one as it includes some additional features like time travel, multi-cluster, materialized views, so makes the platform more rich. Business Critical adds more security capabilities on it like uh, private link, try-secret secure, business continuity in terms of database failover failback. Now, in this trial account for this lab, you can even choose standard. The thing to keep in mind is Snowflake gives you $400 and 1 month of free trial account. You can create more trial accounts with different email IDs. But if you want to get the most of this, then you can start with standard. If you want to play around with more features, then you can choose enterprise. So I'm just keeping enterprise checked here. The next thing you need to do is pick one of these cloud providers. As you can see, the three major cloud providers, Azure, AWS, and GCP, are shown here. Those are the environments where Snowflake is available. And then you can choose a cloud region which is perhaps closest to you or the one of your choice. In production environment, you will most likely keep your data localized in the region you're operating from or the closest region where you're allowed to keep data in. Now, when I look at Azure, I can see the Central India being the top one. So I can use that to get started. Now, I have already created a trial account, so we don't have to go through this process. But once you click on this Get Started link, you get an activation link from Snowflake. You click on that activation link and use your username and password to get started. Once we have that, you log in into Snowflake account and this is how the UI looks like. There are a number of elements and tabs on this UI. It's quite a lot of functionality. We'll go through each of them later, but let me just touch upon the key ones required for this lab. So this is the data tab where we store the data. Now, if you recall the Snowflake architecture layer, we talked about 3 layers of architecture and the middle one was optimized storage. So the layer where we are storing the data, right? So this data tab basically corresponds to the storage layer. Now you can see here we have bunch of databases and within the database we have a schema. Then within the schema we have tables, views, which are more for the structured data. And then we have stages which are required for storing file data. Yeah. So be it structured or unstructured data, Snowflake stores them under this database container. This is how the hierarchy looks like. So if I want to go ahead and create a new database, all I need to do is go create on plus database and give it a name. I'm gonna call it testdb and then create it. It creates a database and by default it populates a schema called public schema underneath that. Then I can go ahead and create a table, create a stage to put some files over there and so on. So when you create the database, all you need to specify is a name. Snowflake does rest of the job automatically. As you keep writing the data, Snowflake will assign it capacity on demand. All right. In the data tab, you also see another thing called add data. This is newly introduced. So you can have some of these connectors to load data into Snowflake tables. For example, this lets you load data from your files on local system or from a stage and then load them into a table. You also have connectors for ServiceNow, for Google Analytics, and then there is SNP connector for SAP and so on. So there are a number of connectors which Snowflake provides to get data from various sources into Snowflake, and they're adding more and more. These are for loading data from the object stores like S3, Azure Blob Store, and Google Cloud Store. So that was one of the most important tabs, I would say, data. The next thing which you would notice is this admin here, which is required to manage this platform. Yeah. So you will notice that I'm logged in as a sysadmin role here because I have chosen that as my user role in this UI right now. But you can choose the role as account admin, which has more privileges. So these are some of the system provided roles out of the box. When you choose account admin, you can see the UI gives you additional details about the cost, how much credits are we spending, how much dollars are we spending, and where. Yeah. However, the important thing I wanted to show you from the architecture side was this warehouses, which are the compute clusters. Again, going back to the architecture, we talked about this elastic multi-cluster compute layer. Warehouses are nothing but clusters of those compute clusters which operate on the data. Yeah, so this is where the processing happens, the query processing as we talked about. Again, to create a warehouse, you just give it a name. You specify a type. So there are two types of warehouses. There is a standard and there is Snowpark optimized for larger memory operations. For now, standard is fine. We will talk about this later. Then you pick up a size. This size essentially denotes how much compute power we want to bring for our processing work. Yeah, so all the way from 1 credit to 512 credits per hour. This also in a way translates to how many nodes are operating on the data. Yeah, so this might mean just one node, this means two nodes, and so far. So you can see as we increase the size, we are getting more compute processing power, and that is evident when you operate on queries with these sizes. You would see that queries perform better when you increase the size if you have larger data to process or the queries are more complex and so on. There are some advanced options which are very important. Those are also by default selected here. So auto resume and auto suspend. Auto suspend ensures that the warehouses are suspended when there is nothing running on that warehouse. We can specify the duration. I can even go down to the matter of saying, hey, use 0.2 minutes of inactivity interval, and if nothing comes on this warehouse, suspend it. That means we will not be paying for this warehouse after that. But the moment some query comes in, then the warehouse should automatically resume. So one quick suggestion here, keep them checked all the time. However, change this period based on your best settings you require for this environment. For example, for ETL activities, having zero point 0.1, 0.5 minutes of inactivity is enough. If it is a BI kind of requirement where you want more caching, then you can let the default of 5 minutes or 10 minutes be there. But since this is a trial account, I will say to save the credits, keep it to the minimum, and I'm just keeping it 0.1 for now. Then you would notice multi-cluster warehouses, which basically lets you have more clusters spin up automatically within this warehouse when more queries are hitting this particular compute. Yeah, so you can specify a minimum number, a maximum number, and how we should scale. Should we be conservative or be aggressive? We will talk about this later. So this is more like horizontal scaling or bringing more compute immediately. Or you can choose a vertical scaling as well, as you have more complex queries or queries which scan a lot of data. You can say that, hey, I want to automatically scale this compute up by a certain factor, and you can also let Snowflake do this at its own discretion without any limits. But you can put a gating here saying, hey, I want to keep only 8x scale of my warehouse size. And then you can go ahead and create this warehouse. So now we got another compute cluster, and we can suspend this so that we don't spend any credits on it. So you can see I have 4 clusters of compute now, and any of them can operate on any of these database tables, right? So from a separation of compute and storage standpoint, let's say this is the table I want to query, and I want to use one of these compute clusters. I can totally do that as long as I have privileges to operate on it. And you can see we have owners here. We have we can edit the properties of this virtual warehouse to change the properties we just set in. You can also see the permissions here and give permissions to other types of roles as well, right? What kind of permissions I want to give. So as long as you have permissions on this compute clusters, you can use any of them to operate on any of the tables. Again, you need to have privileges on those tables as well. So these are two most important things from an architecture standpoint: the compute clusters under warehouses, and then database objects where we store the data. Yeah, so that completes the 2 layers I just showed you: storage and warehouses. And then cloud services is kind of brain behind the system. So the entire interactions we are doing with Snowflake environment via this UI is all essentially going to the cloud services layer, and that is then operating on the Snowflake environment. The access controls, the transaction management is all getting taken care of through the layer. Right, so that was about compute and storage. Now, another important element here is these projects. This is where we write the code to interact with Snowflake, also build dashboards for getting some visualizations. Using Streamlit, we can build some Python-based visual applications, and also create applications using these UIs which can be offered on the marketplace. Then you have AI and ML tab to create models, ML models, and use them on top of data. We'll come to each of these tabs later in detail, but I'm just showing you a quick walkthrough. This is the monitoring tab where you can see what is happening on this account in terms of queries, the copy jobs to load the data, and so on. And finally, you can search data within the Snowflake account. So let's say if I want to just search test, you can see that Snowflake documentation around testing, any marketplace apps, worksheets and dashboards, which start with test, right? Okay, so let's go to home and get started.